Hi folks, and welcome to Deployment Automation, part of our ongoing series on modern DevOps practices. Today I want to talk about the tools, technologies, and processes used to embrace deployment automation. So we'll be covering aspects of infrastructure as code, policy enforcement, and the automation that wraps all of that together. My name is Sandip, and I'm a DevRel engineer, and I'm focused on helping teams adopt better DevOps strategies. I've been with Google Cloud for about 7 years, give or take, helping teams of all shapes and sizes adopt and optimize for cloud. You can always find me at CRCSMNKY, that's Circus Monkey, on Twitter if you've got questions or comments about DevOps, Google Cloud, or if you just want to say hi. So, how does automating deployments and deployment automation generally help us improve delivery and operations performance, right? For those of you that joined us at our last session last month, you remember these are the 4 key metrics, right, of measuring high-performing software delivery teams. 2 speed metrics and 2 stability metrics. So where does deployment automation fit into all of this? Well, first and foremost, this approach helps with deployment frequency and time to restore. Right? If you're automating deployment operations, that means you're speeding up your ability to deploy software on a regular basis, which means ultimately it gets easier to deploy that software, increasing that frequency. And if errors in production are found, these same tools and techniques and approaches are useful for deploying fixes or new versions of that software. So the faster we can deploy or the more quickly we can deploy means we can remediate a broken service much more quickly. And if we get that automation part just right, we tend to see teams adopt policy enforcement as part of that, which ultimately helps them ship fewer broken services. So it has kind of a secondary effect on change fail rate. And even as part of change fail rate, teams with really good automation practices find it easier to spin up environments that match production or look like production in their test environments, which means their tests that they're running now uncover issues before they ship that code into production. So that's where it benefits in those sort of trailing indicators of delivery and operations performance. Now, when we look at the leading indicators, right, of DevOps performance, these are the things that tend to predict sort of success for us. Along with improving some of that delivery performance, there are also some key capabilities that are indicative, again, of high-performing software teams who incorporate deployment automation. So chief among them are things like bringing security and policy enforcement earlier into the DevOps process, right? So now we're evaluating policies as we're writing some of that code, as it's getting committed and tested before it's even kind of rolling out to prod. And we're applying sort of version control and a bunch of automation to our software and infrastructure configurations, right? This is, again, a critical capability. And all of this together has the benefit of driving or reducing the toil that drags teams down, right? So that's where a lot of this DevOps work really starts to pay off. Now, deployment automation starts with infrastructure as code, but it goes way beyond sort of just Terraform all by itself. A good infrastructure as code approach starts with the configuration and adds a policy component. And then there's this distinction between applications and base infrastructure, right? We may have different approaches for both. We may have similar approaches for both. It really just depends. But there are processes and practices that should be incorporated for base infrastructure or application infrastructure. Now, when you look at this, right, these are some of the resources that we tend to see when we talk about these components, right? For configuration, that's either, kind of captured in scripts or in manifests. For policies, that could be things like running source checks or, maybe some rules or some guidance around what we can or cannot deploy. And then on the base infrastructure, so on the bottom half, that may be our compute layer, right? So either things like VMs or running on Kubernetes. And then the application infrastructure is kind of moving up a little bit. And now we're talking about things like packages or containers, right? So this is where we kind of put all that stuff together. And to me, deployment automation is really about tying all of that together into a cohesive approach. So we start at configuration, we run some policy evaluation and enforcement on that config, and then on the other side of it, we get through to application infrastructure and base infrastructure. And there's automation that ties it all together such that, the way we would measure success here is that a change in the configuration can kind of make its way all the way through this entire system while still maintaining a strong security posture and without needing any imperative or manual operations. That's when we know we've got the deployment automation kind of nailed on a regular basis. So when you think about applying some of that approach to kind of an application, right? First, we have to decide what the base infrastructure components are and what the application infrastructure components are. Now, here's a sample application and its related services, right? Sort of standard kind of service-oriented approach. The thing we have to use as our distinguishing factor, though, is really kind of around ownership and maintenance, right? Who is responsible for a particular resource? That's going to help us kind of figure out that dividing line. Now, if you think about it from the view of kind of dividing that responsibility up, if we start at the bottom, things like compute, networking, identity and access management, activating or enabling APIs, and even kind of moving up to some of that shared database infrastructure, that could be considered kind of base infra. And then everything above that becomes the application infrastructure. So there it's more about getting the containers onto the right compute or getting the services running on the right VMs. Now, I will say in this example, at least, I think there's a case you could make that, if those databases are owned only by this application and the application team wants to take over sort of the life cycle and management of it, they could actually become part of the application infrastructure. But I think this is an argument you kind of have with your own teams. And again, who's responsible for running what, right? That's really the important aspect. It's about who's going to make sure these systems stay up and running. That's how you decide that responsibility line. And so, again, now that we're kind of honing in a little bit, if we know we have application infrastructure and we know we've got sort of base infrastructure, how do we figure out which tools to use, right? It's particularly around GCP and Google Cloud in particular. So there it kind of depends, right? If your experience and expertise is really heavily weighted in VM-based deployments, the choice might be more straightforward. You might just use Terraform for the entire stack, the top and the bottom. But when we talk about containers and Kubernetes, the infrastructure as code story can get a little bit more complicated. That's where I start to have Terraform kind of associated with base infra, because I think that still works really, really well. And we use the Kubernetes Resource Model, or KRM, to sort of define the application layer, right? The application infrastructure layer. It really depends on where your experience is, where your expertise is, and the sort of practice you're trying to build around deployment automation. I've seen a lot of teams really stick hard to Terraform, even if they do use Kubernetes and orchestrate a whole lot of containers, because Terraform makes sense to them, right? So that's the approach they've taken all the way through. Some have really adopted sort of Terraform for the base, and then KRM, right, the Kubernetes Resource Model, for all of their applications and application dependencies. And I would say a very, very small number of teams I've seen actually take the KRM approach and use that across their whole stack. But I would say that's a little bit more of an advanced case. But the sort of canonical example I often use here is, Terraform is used to set up the sort of foundation and maybe to create like the Kubernetes clusters. And then KRM is used to deploy applications and any of the application dependencies in those same clusters. Now, again, this is not hard and fast guidance, right? What you see in the slide may not match your own experience and expertise, but that's where we have to kind of at least understand both sets of tools and then decide which one makes the most sense for us to incorporate. Now, if you're starting with Terraform, getting started with Terraform and GCP is pretty straightforward. You basically create a main.tf and you include the required provider setup. Most of this is just boilerplate. And along with, once you get that bit of boilerplate done, you're sort of off to the races. And from there, you can define variables and outputs that you want to have. So if you want to parameterize things like, project ID, region, or zone, you can put that in your variables. And then if we need to define sort of the output that's going to happen from any output information we need from the running of these scripts, then we can put that in the outputs.tf as well. Now, we don't have time to go through all of the supported resources in the provider that we have with Terraform because it's a pretty lengthy list. I think the safest way to think about it is if there is a public API for a Google Cloud resource, we're more than likely to support it in the official Terraform provider. But that actually also raises an interesting point. While the provider brings you API like resource operations, for creating, reading, updating, deleting, in itself is not idiomatic. It's like comparing the use of API endpoints versus using the G-Cloud CLI, right? The API lets you do all manner of operations, but there's a lot of boilerplate and sort of busy work involved there. Whereas with the G-Cloud CLI, you can create a Kubernetes cluster with some pretty same defaults in a line. And so that's where the Cloud Foundation Toolkit comes in. The CFT is a collection of Terraform modules that capture our idiomatic best practices and help you simplify your Terraform code quite a bit. So once you've got a project set up with identity and billing, you can basically use Cloud Foundation Toolkit from everything above that layer. So it covers all manner of configuration. Basically everything up to running your individual workloads is covered by the Cloud Foundation Toolkit. So you can imagine creating things like custom GKE clusters or custom, complex networking configurations. All of that is made so much easier because we've taken that sort of idiomatic approach and we've simplified, so there's a lot less busy work you have to do. And a good example of that is the code you see right now on the screen, right? Creating a GKE cluster that's, maybe got on the beta release path and it's got some public facing capabilities and it's got some features. Deploying all of this with a custom node pool, setting things like OAuth scopes. We can do this with the bare Terraform provider today, but it turns out to be a lot more code, right? And that's why we like the Cloud Foundation Toolkit so much, because it lets us express the same outcome, but with a lot less boilerplate, a lot less code. And advanced use cases are well supported inside of CFT as well. Now, a good example of this is setting up workload identity. For those of you that have done this before, setting up workload identity and GKE involves quite a few steps. Now, we can capture all those steps inside of the Cloud Foundation Toolkit, and basically all we ask of you is that you provide a few parameters up front, and then we can actually do all the heavy lifting of setting up workload identity behind the scenes without having to expose all of that work to your Terraform code itself. And so with workload identity, for example, you need to assign and associate Kubernetes service accounts with Google service accounts. We don't have time to get into the why, but essentially that's what happens behind the scenes. To do that requires a bunch of sort of, again, specific ordered steps. With this little snippet of code from the Cloud Foundation Toolkit, it gets done for you pretty automatically and assigns those roles for you right out the gate. And it takes care of connecting all the stuff in the background as well. And the same is true of additional service account sort of work, right? If we need to create service accounts and create additional service account bindings and set up things, we can actually, again, take all that work and do it in a very idiomatic fashion. So if you were to look at how this is done with the G-Cloud CLI versus the API, you'd see that the G-Cloud approach is a lot fewer steps. It kind of looks like this, whereas the API-based approach is a lot of busy work in carrying in inputs and outputs from one step to the next. Now, again, we don't have time to go through every little bit of the Cloud Foundation Toolkit or even cover what's in the Terraform provider. But what I will tell you is that the Terraform provider is a good bare bones place to start, and the CFT is really where you want to take advantage of, again, the idiomatic approaches to building Google Cloud infrastructure. But along with that, we also have a series of good kind of Terraform best practices, right? We have a private catalog that you can actually use. So if you want to create your own modules, and that's a big part of using Terraform, right, is we want to capture reusable code in modules and not sort of copy paste. If you want to have your own modules for your own teams, we actually run a private catalog service as part of the project. So you can actually store your modules there for your teams to then consume from. You can actually also import existing GCP resources into Terraform. So let's say you did a bunch of point and click deployment work or a bunch of G-Cloud commands, deployed a whole lot of infrastructure, and you want to turn that into Terraform. We actually have a tool called Terraformer, which will take all that infrastructure you've created and spit out Terraform code that matches up really well. And we can do things like enforce, policy evaluation and policy compliance using a tool called Terraform Validator. And we also recommend that when you're using Terraform, you store the state, right? That TF state file needs to live inside of Google Cloud Storage so that multiple teams can kind of hit it. And I would actually say even beyond those best practices, the other one I would definitely recommend you look into is this approach of managing infrastructure as code using GitOps and Cloud Build together. So in that case, no one actually ever runs Terraform commands directly. You have a Cloud Build pipeline that's set so that every time there's a change to your configuration, it automatically spins up your Cloud Build pipeline, which runs all of your Terraform work and then kicks out the infrastructure on the other end. Now, that was the Terraform part. Let's talk a little bit about the KRM, or the Kubernetes Resource Model approach. So the KRM approach is a little bit different, right? Kubernetes objects are configured and controlled kind of using a declarative configuration, and they express kind of the desired state, right? That's how when you think of KRM, right? When you tell Kubernetes what to do with your pod, you're giving it the end state you want to achieve, that I want this pod deployed with this metadata and these settings, etc. Now, the way that configuration is expressed, that YAML or that JSON, that format is called KRM. Now, if you think about the way KRM works, it also employs kind of this configuration as data approach, where once something is configured, it's not interpreted or it's not transformed. It is exactly the way you wrote it, right? It's kind of carried through. There may be additional metadata added to it, but it's exactly the way you wrote it and represented. So it doesn't have a lot of the sort of same variability or parameterization in the same fashion. And the way this configuration also works with the Kubernetes API is that because you're expressing your desired state, the Kubernetes API server is always reconciling. It's always trying to make sure that the way your pod is running matches up to the way you defined and you declared the state for your pod. And so that's kind of the basics of the model. But it actually is a model that applies to a lot more than just sort of applications. We can also use it for infrastructure as well. Now, before we get to the infrastructure part, the good news is that for kind of ecosystem usage, if you build and specify your base or your application infrastructure using the KRM approach, it works with anything that can work with Kubernetes, because all of these things all fit together. They all have the Kubernetes API as their sort of common framework and their common understanding. So, tools like admission controllers or custom operators, things like policy enforcement, or even continuous delivery mechanisms. If they work with Kubernetes, they can work with this sort of KRM style approach for infrastructure. And a lot of the sort of development tools we tend to use, like Kustomize or Kept or Helm, those also fit really well with the KRM approach. Now, when you take Google Cloud and you kind of add in the KRM or the Kubernetes Resource Model approach, what you get is something we call KCC, or the Kubernetes Config Controller. And it allows you to provision Google Cloud resources using KRM objects, right? So essentially, the same way you would declare or specify a pod or a deployment is the same thing we can use to configure and deploy a Cloud SQL database or a Kubernetes cluster. So in practice, what that looks like is we run Config Controller. It's a hosted service to provision and orchestrate Anthos or Google Cloud resources. And you can manage those same Google Cloud resources using the Kubernetes API. So if you have a bunch of Kubernetes API expertise and experience, this approach might be a natural fit, right? Now, the config connector resources kind of build on top of the Kubernetes RBAC and audit capabilities. So it's a good fit there as well. And you end up kind of expressing your application dependencies the same way you specify your applications, right? In this sort of desired state configuration. And a good example, again, kind of thinking back to that retail one, is things that are tightly coupled, right? We may have a product catalog service that requires on a cache, like Redis. No one else needs that Redis except for that one service. Because those two things are tightly coupled, they probably would make sense to be expressed as in this KRM style, where I express the kind of pod and application or the deployment for that service, and I express the cloud memory store for Redis service in the same sort of style and approach, because those two things fit together really clearly. Now, again, just as an example, if you want to compare sort of, kind of similar objects to what they look like in the KRM world, on the left, you've got a Kubernetes pod manifest, you all are probably familiar with. And on the right, we have the Cloud PubSub service, where I'm enabling the Cloud PubSub API, and then I'm actually creating a PubSub topic. So it looks pretty similar, right? The YAML starts to bleed together after a while as you kind of dig in here. But it's a very simplistic and straightforward approach. I am telling the config controller, I want to enable this API, I want to have access to the service, and then I want to create a topic in that same way. And if you, again, dig in a little bit further, we have examples around here on the left where I'm creating a Redis instance for Cloud Memory Store. Or on the right, I'm creating a Postgres database for Cloud SQL with high availability, right? So a lot of the same tools that we can, again, do with things like Terraform can be expressed using this KRM approach. And if it makes sense for you to run as containers in Kubernetes, that's part of your application infrastructure, then this approach may make a lot of sense. And the other thing to remember here is that this is not brand new stuff. This is actually building on a lot of existing approaches that we've had in the past, right? We have had Kubernetes API actually control infrastructure and create infrastructure objects for quite a while. So for example, we've had, ingress capabilities inside of Kubernetes. Well, that's actually configuring your L7, load balancer. Or in the service manifest, you can actually configure a load balancer there, and that creates an L4 load balancer. So we've actually had this practice existing for quite a bit of time, where Kubernetes API objects can actually control and configure and provision cloud infrastructure behind the scenes. Now, just like the Cloud Foundation Toolkit, we actually also package a lot of deployable and reusable configuration and policy objects as something we call blueprints for KRM and for KCC. So for this, we use a different set of tooling, right? We use Kept to drive a lot of the customization and the validation needs. And we supply policy as well for sort of common configuration and security needs to make sure that you're not launching stuff without having some of the policy evaluation and policy compliance aspects baked in. So I would say check out the Blueprints project if you are interested in KRM and you want to start using that to deploy infrastructure. Now I want to walk you through a couple of quick examples that build a little bit from the ones I showed earlier. So, first thing you tend to do when you're working with Google Cloud is you have to enable APIs. And so here's an example of how we're going to do that. We're going to enable the PubSub API and add a couple of additional annotations that specify some of the behavior we want. And we're going to do that for two things, PubSub and for Redis. And then when we start to create resources, we're going to create not only a PubSub topic here on the right, but we're actually also going to create a PubSub subscription. Right? If you sort of squint a little bit, this actually kind of follows very closely, again, the G-Cloud sort of CLI approach, right? We're not doing bare API operations. We're still following the idiomatic approach. It's just wrapped up in this YAML that looks very much like Kubernetes API manifests. So that's a little bit of the KRM background. Now, before we finish up for this session, I want to talk a little bit more about structural integrity. Right? This is where we have to make sure that all of our configuration, right, all these infrastructure as code components, whether Terraform or the KRM style approach, that we still have a good story around policy evaluation and policy compliance, because that's a big part of deployment automation. We've got to make sure we're not breaking any of the rules that we set up as part of our organizations when we're deploying this infrastructure, whether it's base infra or application infrastructure. And so when you think through this, if you follow the Terraform path, right, there we're going to have some policy objects, and we're probably going to use either Open Policy Agent or Forseti, which is a tool from Google Cloud, to enforce those policies back in. And the same approach makes sense with KRM. We have policy templates and constraints, right? And then we either enforce those using Open Policy Agent or Forseti. It just depends on which tool you pick. And the way that looks in practice, right? You always want to have, as part of your CI/CD pipelines, right, or as part of your GitOps approach, you want to have some of that validation baked into your automation and your deployment. So here, whether dev or ops or infrastructure teams, when they check code in, when they check infrastructure as code, code into Git, there's a validation step that runs. And it makes sure that this IAC code has not violated any corporate policies. And then it can let the CI/CD process go from there. And that'll can kind of run and deploy either base infra or application infrastructure. And this is something that we've got captured in a couple of examples using Cloud Build across our documentation. So I would take this to heart and really look into this. When you're doing this with Kubernetes and the KRM style approach, it very much follows the exact same path, right? Teams commit that KRM, those new manifests, to their Git repos. There's a validation step that runs in Cloud Build that checks for any policy violations and then kicks it back. And if it's good, it lets CI/CD continue. And again, we end up with base infrastructure or application infrastructure. Now, we covered a lot today. We can't go into as much depth as I would like to, but I'm going to leave you all with a little bit of homework before we get to the next session next month. And so some of these links we'll put in the description below the video here, but just sort of generally using Google Cloud with Terraform, it's a great place to get started. The architecture that I shared earlier, this infrastructure as code and automation approach using GitOps and Cloud Build and Terraform, there's a link that's also down there. There's an example of managing GKE clusters with config controller and KRM using the blueprints approach that I talked about. And the last thing I would want to mention, again, one of the most important aspects is creating policy compliant Google Cloud resources. You'll start to hear this from me again and again, but I think policy is super important, and it puts some bumper bowling and some guardrails up so we don't break things or shoot ourselves in the foot. Now, last month, we kind of kicked off the Modern DevOps series. This month, we're talking about deployment automation. Over time, we want to cover more and more topics. So over the coming months, we're going to have talks on things like building software delivery pipelines, running software at auto scale, right? Securing your software supply chain, kind of learning about running reliable services and having that blameless culture as part of SRE. And we're going to probably talk about some of the ROI of doing a DevOps transformation as well. So I will see all of you in a month. Thank you very much.